on this computer. There we go. Very good. If there are no objections, if you do object to the recording, just let me know and I'll turn it off. All right, so let me share my screen. All right, we're working on Monday and Tuesday, Unit 3, Lesson 4, Day 3. Clicking on this link will turn us over to here, right? We are working on exponential depreciation. This is Day 3, Days 1 and 2. We're about linear depreciation, all right? 2 learning targets. Let me kind of get this a little bit bigger here. So
is this the same one from yesterday?
Yeah, same one from yesterday. We're working on the same assignment from yesterday because we didn't finish yesterday's. All right, and I don't even know if we're going to get done today. There's a lot to learn yet. So we'll see how it goes. I was hoping we get this done in 2 days. I can write, interpret, and graph an exponential depreciation equation, right? This idea that you can put the data, you can look at a situation, like a real world situation, and kind of build an equation. That's where you go from a word problem to like a function notation type of situation, to then interpret what that exponential depreciation or decay equation means, and then be able to graph that using your calculator. And the second learning target is I can manipulate the exponential depreciation equation in order to determine time, original price, and depreciated value. We're not going to play around with time so much. That gets into natural logs, which I'm going to show it to you, but we're not going to mess around too much with that. All right, we went over the vocabulary last time. You might as well go ahead and we're going to select those learning targets right now. We're going to copy those because I'm going to ask. Oh wait, no, you've already probably answered that question, right? Probably you've already got your name in here since you're editing this, and you already have the learning targets. So no need for me to go over that. Let's just review what we've learned so far. Here's the video for yesterday's class period. We looked at this data. We stuck it in our calculator, and we found that it created a nice straight line on the calculator. So we chose this to be linear, if you'll recall. And then we let's see, we entered, we graphed it, right? We took this and we graphed it. This was the warm-up. And we put the equation into y equals, and we found when y is 0, we found what x was, and that kind of thing. So we're talking about linear depreciation. And this is basically, this little formula here is the general look of what an exponential depreciation looks like. We have y equals a variable, times the expression 1 minus r. R is the rate expressed as a decimal out of 1, and then x is an exponent. This is so important. This little caret, I was missing that last time. This little caret, it makes this an exponential function. Without that little caret, look at your keyboard for a second. If you look at the 6 key, right above the 6 is a caret symbol. To make a caret happen on your keyboard, you put Shift 6. That's how I made this little symbol here, Shift 6. That's the caret, and this indicates to raise this expression here to the x power. All right, now x could be a lot of different things, y could be a lot of different things, but a is always going to be the same kind of thing. It's going to be the start of the function. So in this case, we're talking about cars and depreciation. A is always going to be the original price of the car when we started running the function. 1 minus r is the rate. So if it's like 8%, right? If we're doing like 8%, let me get my calculator over here. Oh, I gotta get out of that. Okay, if I had 8% as my r, I take the 8, I divide by 100 to express it as a decimal, and then 1 minus 0.08 is going to be what goes inside these parentheses. Inside these parentheses is going to be 0.92. A number less than between 0 and 1 indicates that you have depreciation. A number between 0 and 1 in here indicates you have depreciation. If you have a number 1 or greater, you are, appreciating. Well, actually 1, you're staying the same, but anything above 1, you're appreciating. It's gaining in value. Okay. And then we looked at the things like this, right? This is the classic look of an exponential function. We have this curvy shape, right? This is best modeled as a exponential rather than a linear. Yeah, rate should always be just expressed as a decimal, right? Okay. And then example 1, we put the data in our calculator, and we went into, I don't think I have data in my calculator right now. Let me see if I do. Oh, I have data in my calculator. So let me just show you this. I'm going to press the stat button. I go over to calc, and if I want to run an exponential regression, EXP, REG, I got to go all the way down to this right here, EXP, REG, enter 5 times, and then I get the same, my numbers are different, but it looks like this. Y equals a times b raised to the x power, where a is where the function starts. In this case, it's 74 and some decimals, where b is a rate. And this one, it's increasing by about 1%. You see how I kind of see that? I know it's increased by 1% because it's 1 plus 0.01. So about 1.6%. If I want to go out further into the decimals, about 1.6%, this function is increasing whatever I've got in my calculator right now. This exponential regression, I see that it started at 25,921. This was probably the original value of the car when it was first purchased. And then B tells me it's a value of 0.91, or 0.918, so maybe 0.92. If I can find out what that percentage is by taking 1 minus 0.918, that gives me 0.082. Times that by 100, turn that into a percentage, and then I got 8.2%. This one is decreasing by 8.2%. All right, and maybe I could round to different things there, but I'm just trying to review what we learned last time. All right, so we were sticking data in our calculators. All right, this is example 2. Example 2 is where you learned that B, whatever B is in your calculator, again, stat, calc, go down to exponential regression. All right, this is what I'm just going back to the stat exponential regression thing. B here is always equal to 1 minus R, right? Just so you know, B is equal to 1 minus R. That's kind of what you have to remember there. And we can find out what R is if we know what B is. If I know what B is, like I'm looking at B here and I'm saying, 1 minus 1.01, it's going to tell me it's increasing by 1.6%, right? And the 0.92 told me that's, so I'm getting the rate from whatever I see as the B value. That's what we learned for number 2. And we answered all these. Now we stopped right here. Why we stopped right here was because I have like 20 questions I'm about to ask, simple math things. And I kind of want to review for you how to manipulate exponents, because I think exponents are still a little iffy for some people. So let's think about these. What
16.
is 4? Okay, 16, great. How'd you know that?
I don't know. I just know. This is one of the
Okay.
things.
So so great. You just know that 4 raised to the second power is 16, because 4 raised to the second power is the same thing as 4 times 4. It's 4 2 times, right? Multiply 4 by itself 2 times. 4 times 4 is 16. Therefore, 4 raised to the second power is 16. 4 raised to the third power.
64.
It might be. Geez, it's gonna be 16 times 4. Yeah, 64. How'd you know that? Did you just have that memorized?
Yeah.
Okay. Well, great. Wow, you know some crazy math facts. Even I don't have that memorized in my head. But what about this one? What is 4 raised to the? Did I hear it?
2.
Oh my gosh, yes, it is 2. How'd you know that?
It's not. I thought it was 1/8.
How did you know that 4 raised to the 1/2 power was 2?
I don't know. It's called doing the math work.
Oh, great. Wonderful. See, I was worried you guys didn't know fractional exponents. I was worried like, oh, they might not know fractional exponents. I need to review this. But yeah, so as Mr. K says in the chat, 4 raised to the 1/2 power is the same thing as the square root of 4, which is asking what number multiplied by itself gives me 4. And then that's 2, right? 2 times 2 is 4. Therefore, 4 to the 1/2 power is the same thing as the square root of 4, which is the same thing as 2. Okay. What about 16 raised to the 1/2 power? 8. Well, wait, 8? 8?
Oh, 4.
6, right. 16 divided by 2 is 8.
I was
But
looking at the wrong question.
16 raised, yeah. So you can do that if you're ever confused on these. Like, here, look at my calculator over here. 16, I can raise this to the 1/2 power, and I can actually look at what it is, right? It's 4. Why? Because 4 times 4 is 16, and the square root, 16 to the 1/2 power is the same thing as the square root of 16. These are the same kind of ideas. So for this one, 4. All right, hold on, I have to cough. All right. What about 64 to the 1/2 power?
This one is
8.
8. This one's 8. 64, 1/2 power. Great. You guys know this. Okay. This you don't really need, but what is 4 raised to the -1? I'm just testing to see if you know.
0.25.
How did you know that?
Doing the math work. Also, I put it in a calculator too.
Oh, great. So you put it in the calculator. That's wonderful. Like that's fine. So you raise it to the minus -1, right? You can find out it's same thing as 0.25. So either one of these answers is right, because 0.25 is the same thing as 1/4. So you could do either one of these. So I want you to get this idea that 4 raised to the -1, really all that does is it takes the number you just had, the 4, and it puts it as a denominator with 1 above it. So 4 to the -1 is 1 divided by 4, or 0.25. Expressed as a decimal. Okay. What is 1/4?
0.25.
Yeah, it's the 0.25, right? I wanted you to know that fractions can become expressed as decimals, right? We can take any fraction, we can express it as a decimal. All right, what about 8 to the -1? This should be pretty easy.
0.125.
Yomari, are you fast on that calculator, or you just have these memorized?
Some of them I haven't memorized, and some of them I'm using the calculator for.
So Yomari maybe went to the calculator, or maybe just had this memorized. I don't know. But 8 to the -1 is 0.125, or otherwise known as 1/8. So you could use either one of these as correct, right? Because 1/8 is the same thing as 0.125. Oh, Mr. K has a trick. You want to talk about this, Mr. K? He wants to say if it's 8 raised to the -1, then that's the same thing as 1/8, I'm guessing. Other way around, right? 1/8. All right. What is 1/8? Well, we just kind of learned that 1/8 is the same thing as 0.125. All right, same thing. 1 divided by 8 is the same thing. Again, I just wanted you to know that sometimes the fractions and decimals, fractions can be expressed as decimals. Decimals can often be expressed as fractions. 4 raised to the 4th power. This is just like a little thing. What's this one? 4 raised to the 4th. 256, right? Because it'd be 4, which is 4 to raise to the 4th power is the same thing as 4 times 4 times 4, right? So what I have to do to get this, I have to be 4 times 4, that's twice. That gives me 16, times 4 again, which gives me 64, times 4 again, which gives me 256. All right, so 256 all the way at the bottom. Boop. There we go. Okay. But now, can we figure out what is 2 raised to the 2nd power, which itself is raised to the 1/2 power? This one's a brain scratcher, right? Well, let me try it my calculator, right? I'm gonna do parentheses 2 raised to the 2nd power, right? Oh no, I want to get rid of that, and I want to bring this down, and I'm gonna raise this all to the 1/2 power, to the 1/2 power. Let's try this on our calculator. Well, looky there. That becomes
Still 2. How does that work?
How does that work, right? Well, let's think about this. What is 2? Let's do the parentheses first. What's 2 raised to the 2nd power? That's 4, right? 2 raised to the 2nd power is 4. What does raising something to the 1/2 power mean? It means taking the square root, right? It means, what is the square root of 4? Oh, that's 2, right? 4 raised to the 1/2 power, to the 1/2 power, is the same thing as 2. So what do? I just got my 2 back. If I raise it to the 2nd, and then I raise it again to the 1/2, I get my 2 back. So the answer is 2. Let's look at another few of these more. Okay, what's 2 to the 3rd power raised to the 1/3 power? Ooh.
2.
Ah, you know it, right? Right, it's 2. Let's think about what's happening there. Yeah, I'm not trying to be tricky here, but 2 raised to the 3rd power is 8. And then what is 8 raised to the 1/3 power? To the 1/3, it's going to be 2 again, right? We raised it to the 3rd power, and then we brought it back down to where it started because we raised it to 1/3, right? So we want to choose 8 for this one, not 2. Oh, I'm sorry. 2 is the answer, right? Okay. Let me try to be tricky now. What's 4 to the 3rd power raised to the 1/3 power? You don't actually need a calculator for these. You can, wait a minute. Yeah, it's it's going to go back to what it was, right? If you raise something to the 3rd power and then you raise it again to the 1/3, it goes back to where it started. You're undoing the 1/3, raising it to the 1/3 is undoing the raising it to the 3rd, right? because it becomes what you end up doing is you're raising it to the 3 over 3 power.
So it's 4.
It's gonna be 4. It just goes back, right? 4 to the third, 4 to the third.
Man, I don't like this.
4.
Why are
You
they
don't like this?
bullying me like that?
And this is why I wanted to show this to you, because I thought
I mean, it was
some
fun.
of you,
It's fun.
yeah, it's kind of fun, right? I wanted to show you that this works, right? That this, if you raise something to the third power and then raise it again to the 1/3 power, it just goes back to where it was, right? Our 4 raised to the third power is 64, but 64 raised to the 1/3 power is back to 4, right? It just becomes back what it was. And we can do this all over the place. This becomes 4, right? Because it's 4 to the second raised to the 1/2. Now I'm playing around with exponents where it becomes 2 over 2 or 3 over 3. 2 to the 4th power raised to the 1/4. 2 to the 4th power raised to the 1/4. Do we need to see that one?
You mean Alvin?
No.
Like
You don't. You guys don't.
Alvin?
It's 16, right? And then 16 raised to the 1/4 power is 2 again. Right? This will always happen.
I know.
This will always happen. And I think I have, this is the last one I think I have. Do I have more of
Mister,
these?
you know you could just put it all together, right? So if you do 2 to the 4th power and then you press
Oh, I know. Yeah.
the same thing again,
Yeah. I just wanted to show
it'll
it
just
as
put
like,
the 2 within the parentheses.
yes, I just wanted to, I wanted to show people that, that the step-by-step, but yes, I can put it all together. Wait, what did I do there? 2, I need to put it in parentheses, don't I? 2 raised to the 4th power, and I need to put a parentheses here. I need to insert a parentheses there. And if I raise this to the 1/4 power raised to the 1/4, then I should get 2 again, right? Okay, so I need some parentheses in there. I'm not sure why the calculator didn't like it the way I did it before, but all right. Okay, so the 64 raised to the 4th, but then raised again to the 1/4. No one's shouting it out? You can just look at these. You can be like, oh, wait, if you raise it to the 4th and then raise it again to the 1/4, you've just canceled
I
the
don't
2
even know
things.
what you asked. It's 64 again.
It's 64 again, right? It becomes 64 again. Okay, last one. 256. Okay, it becomes 256, right? I'm being tricky today. Okay, here's why. I have some other questions. Here's some understanding questions. Oh, what does the A stand for? And I'm glad you're thinking slope, because that was what it was when it was a linear function, right? With the m times x plus b, the first thing was slope. In an exponential, though, A is really more like the y-intercept in a linear. A is where, what? I talked about in the very beginning of class. A is where,
I don't remember.
It's where the function starts. Where the function starts, or in this case, it's the original price of the car. All right, I need an I in there. It's where the function starts, or in our case, for our purposes, it's the original price of the car. A is the original price the car was purchased at before it started depreciating. What does B stand for? Do you remember what B is? We talked about it. We said that was equal to 1 minus R, right? B is the rate.
Wasn't it the years? Oh, that too.
No, actually, in this case, in our case, the x's are going to be years. So the x variable,
All right.
in other math applications, it could stand for other things, but mostly in our case, we're going to talk about x in terms of years. Yeah, you guys are doing great. So B is the rate of depreciation in our case. Rate of depreciation. If I have a number that's like 1.1, that tells me I'm increasing in value by 10%. Yeah, Javier, we want to hear from you. Javier, you're too quiet over there, right? If I have a B value that's like 0.5 tells me I'm depreciating at 50%. Okay, or 0.4, I'm depreciating at 40%, or 0.92 tells me I'm depreciating at, well, it's going to be 8%. So I'm decreasing. I'm 92% of what I was the last time, which is 8% different than 100%. Okay. Okay. Yeah. Okay. if the rate is 0.92, you missed a lot. Yeah, I'm doing a little review here. All right, so if the rate is 0.92, then what's the B value? Remember, the B is equal to 1 minus R. Oop, I need a minus in there. Minus R. B is equal to 1 minus R. So if R is 0.92, run to your calculator and do 1 minus 0.92. And that tells me the rate of depreciation is 8%, right? If I multiply this by 100, I'll get 8% depreciation. What the? 0.92? You wrote 0.91, right? I'm wondering if we have a confusion. Okay, let's talk about this one here. 0.75, 0.75. B is going to be equal to, right? B is equal to 1 minus R.
25%.
Right. 1 minus 0.75 is 0.25 times 100, 25%. 25% would be the answer. Okay, we did all that review. Which is almost half the class, just so that we can understand what's going to go on in this one here. Example 3. All right, Eamon purchased a 4-year-old car for $16,400. All right, when he purchased it, the car was 4 years old. When the car was new, it sold for $23,000. We can find the depreciation rate to the nearest 1/10%. So here's how we're going to do this. We're going to let R equal the depreciation rate expressed as a decimal. The exponential depreciation formula for this situation is going to be 16,400. That's the price he purchased the car, because in our exponentials, Y is the value of the car right now. Then this is the A part. This is the A of the formula. This is the original price of the car before it started appreciating. All right, this is being multiplied by B, and B is the same thing as 1 minus R, and it's raised to the 4th power because it's a 4-year-old car. So because it's a 4-year-old car, right, the car is depreciated for 4 years. That's that price at 4 years. I need this 1 minus R to be raised to the 4th power. Okay, so it's getting raised to the 4th power. So that's me writing out the formula, the expression. Let me see. Okay. I'm trying to think if there's anything there. Okay. My first step, I have this being multiplied by the expression 1 minus R raised to the 4th power. First step is to get rid of this 23,000. So our first step is we're going to divide by 23,000 on the both sides of the equation, which just gets rid of this right here. Right? I no longer need to worry about that anymore. Now I have 16,400 divided by 23,000 is going to be the same thing as 1 minus R raised to the 4th power. But then how do I get rid of this raising something to the 4th power? And that's why we did this little math practice a second ago, is because before now, you didn't know how to cancel something getting raised to the 4th power, but now you do. Now you know how to cancel this thing getting raised to the 4th power. What you're going to do is you're going to go ahead and raise it to the 1/4 power, because you know that raising something to the 1/4 power just gives you back what you had in the begin with, which means raising this to the 4th by raising it to the 1/4, these two things cancel. And now I have this just 1 minus R. But now my other side of my equation, this needs to get all raised to the 1/4 power as well. Whoa, I know it's getting a little complex. Don't worry, there won't be a test on this stuff. You won't have to memorize this. I basically want to expose you so that you know that it exists.
Okay,
So
good, because this seems to be hurting my brain a lot.
so that you know that you can do it. I want you to know you can do it more than I want you to be able to just do it anytime, right? This is not an essential skill in life. This is just like, you probably should know it's possible. And then when you actually have a situation where you actually need this math, you're like, I know I learned this once upon a time. I know it's possible. I'm going to go to the internet and I'm going to look it up how to do it. All right, so now I have 1 minus R over here. I'm going to subtract the 1, right? Because I got this 1 minus negative R. So I subtract the 1 from both sides, it gets rid of the 1, and now I have negative R left over. I'll divide by -1 on both sides of my equation, and then I have R all by itself, and I can calculate this. In this case, they ran this equation, their calculator. The calculator does all the work here, and it's 0.08. They multiplied this by 100, and they got 8.1%. the rate of depreciation for Eamon's car. He purchased a 4-year-old car. When the car was new, it was sold for $23,000. The rate of depreciation was 8.1%. His car has been depreciating at an exponential rate of 8.1% per year. That's what we just found out. Okie dokie. Now we're going to try it with Davian. Davian purchased a 12-year-old truck for $15,069. When the truck was new, it sold for $36,000. Find the depreciation rate to the nearest 1/10 of a percent. And I think for this one, I think I would like to use a whiteboard. You may like to use a piece of paper. I mean, I personally could do this on my calculator without without actually writing it down on paper, but I think for you guys,
I'm already ahead of you. I got a piece of paper.
Awesome, awesome. Hold on. Okay. So let me see if I got this here. I'm sharing my whiteboard, correct? Am I sharing a whiteboard? Everyone see the whiteboard? What do you see? Okay. I'm going to assume you see my whiteboard, hopefully. So this is the general how we express these. It's A times B raised to the X power. That's generally how we look at these. In this case, Y is my value at any given time. So they told me that his 12-year-old truck has a value of $15,069. The original, remember, A is the original price of the car. Well, they told me what the original price of the car is. That's $36,000. $36,000 was the original price of the car. What is B? B is the thing I don't know. That's the thing I would like to solve for. And in this case, I know that the truck is 10 years old. So I know that instead of an X, I need a 10 there, because X in this case is time. Let's see.
Wouldn't we have to get B by itself first off, or we're doing exponents first?
We do. We want to get B by itself.
Okay, so we're subtracting 36.
So that, not going to subtract 36 because it's being multiplied here.
Oh yeah, we're dividing it.
We're dividing it, right? So there's 36,000. This cancels, but if I do it on that side of the equation, I got to do it on this side of the equation. Okay, so now I'm left with 15,069 over 36,000 equals B. And what is B? Do you remember what B is? It's 1 minus R, right? B is the same thing as 1 minus R, the rate. Yeah, I wonder if we could make the math a little easier by just not messing with that. I'll have to try it. I'm gonna go with how they did it, and then I'm gonna try it. I suddenly see a more elegant solution to this. The way they showed it, it seems more complicated than it needs to be. But okay, I'll go with it. It's fine. All right, I need to get rid of this raising something to the 10th power. How do I get rid of raising something to the 10th power? We just learned this. What can I do to get rid of this thing being raised to the 10th power? Yes. I can raise it to the 1/10 power, which cancels that, which actually what it does is it makes it be raised. I'm raising it to the 10 over 10 power, and raising something to the 10 over 10 power is just the same thing as 1, and raising anything to the power of 1 is just to keep it the way it is. Okay, so I'm going to raise this to the 1/10 power, which means I got to raise all of this to the 1/10 power. All right. Don't worry. The calculator's going to handle all this. So I have 15,069 divided by 36,000. 36,000, all raised to the 1/10 power equals 1 minus R. And then I can subtract 1, right? Subtract 1. And then that gets rid of that. And I divide by -1. Divide all this by -1. And I will find my rate. So now that I have that, let me run to my calculator. Can you guys see my calculator?
No.
No? Okay, so I will have to do a new share, and screen 2. So here I'm going to do the thing I just said I was going to do. All right, turning on my calculator. All right, clear. I need a parentheses. Actually, I'm going to do it with the Mr. K version, alpha, y equals. I'm going to get the numerator over denominator in there. It's going to be 15,069 divided by 36,000. There we go. I need to, let's see, I need to raise this to the 1/10 power. Raise this to the 1/10 power. I will need to subtract 1. And then I will need to divide by 1. So I need to put that, a parentheses in front of all of this. Oops, I wanted, there I go, a big old parentheses. My calculator's going to handle all this for me once I get it there, divided by -1. Looky there, right? So my R value is equal to 0.08. If I multiply this by 3, why is my mouse not working? Oh, it's because okay, I found out why my mouse wasn't working. I had the pen too close to the drawing pad. All right, so if I was rounding the nearest 1/10 of a percent, I'd say it's depreciating. This car is depreciating at 8.3%. 8.3%. Whew, 8.3%. Yeah. All right. That's how to do it. Okay. Class vote. We have 10 minutes, a little over 10 minutes left. Do you want me to give you an opportunity to just do this on your own and try this? Are you biting at the bit in order to try one of these on your own, or do you want me to kind of go through this kind of the way I do it, and you just want me to show it to you? What do you think? Technically, I made the Michael problem so that you could do it on your own, but if you're not feeling comfortable, I don't want to scare you. What do we feel? I think we lost Mr. K. Okay, well, I guess I'll let you do it. I'll let you work on it. I'm gonna give you a minute.
No,
No, we don't want to work on our own. Okay.
I don't.
Okay, all right. Here's how I would do it on my own. I would just do it on my calculator. I'd be looking at this. I'd be like, I would actually just look at this finished problem. It's going to be 1 minus the now price divided by the original price raised to the 1 over how many years it's going on. Okay, so I'm just going to remember that 1 minus, right, a now price divided by an original price raised to the something 1. Oh, I need a parentheses there. 1 over how many years, and then that'll be it. Okay, so I'm going to go back to my Michael problem. Here's my Michael problem. What's the original price of the car? Oh, the now price is $3,983.40. That's the now price. The price it was originally sold at was $18,000. $18,000 is the original price it was sold at. How many years? It was 10 years. 10 years this thing has been depreciating. So I'm going to raise it to the power of 1 over 10. Is that it? Is that everything? I press enter. That looks pretty good. How do I interpret this? The rate is, what percentage is that expressed as a decimal? Displayed on my calculator.
Do we multiply by 100 to figure that out?
You do, because this is expressed as a decimal out of 1. So you multiply it by 100, and obviously you can see it's 14%, right? This thing has been depreciating at 14%. Yep. Okay, I am not going to do these bonus questions, or maybe I will talk about them. Basically what I'm going to do is have you write the equation out in a straight line. So this is going to be a little more challenging. The car originally sells for $22,000. So 1 minus an original price. I'm sorry, no, the now price divided by original price, right? And then raised to the power of 1 divided by years. That's the general formula that I'm getting. Ooh, I need an I in there again. I'm getting this formula right from here, right? I'm just using what they're using right there. I'm going to plug in these numbers. The now price is $4,000. The original price is $22,000. And let's see, in the years 11 years. That's all I'm asking for. It's for you to to write this out as an algebraic expression. It'd be great if you put in like y equals in there too. And then you could, if you were to plug this in your calculator, that would work. That would solve this equation. And then this is it for you. If you love expressing things algebraically, you can do that. Okay, let's talk about this. A car originally sold for $26,600. It depreciates exponentially at a rate of 5.5 per year, 5% per year. When purchasing the car, Richard put $6,000 down and he pays $400 per month to pay off the balance. After how many years will his car value equal the amount he paid to date for the car? So this is going to be similar to like when we have two lines and they intersect at a certain place, but now instead of having two lines, the depreciation equation is going to be exponential. So here's how I play with this. They give me two equations. I might have to, in some cases, I might have to build these equations. In this case, they gave me the equations, so I just put these in my calculator. I see y equals. Whenever I see y equals in a problem, I start thinking, hey, I wonder if I can put y equals, this equation into y equals in my calculator. 1 minus 0.055, close the parentheses, raise it to the x power. That's my first equation. Then I have my expense equation over here. I've got 400 times x plus 600. All right, I can graph these. Oh, I've got some funky stuff going on with my graph. Let me turn the stat plot off. This is a residual graph from my stats class. Stat plot, let me turn the stat plot off. Okay, and then I'm going to zoom, and I want to zoom fit this. Zoom fit, it's choice number 0. There's the curve line. That's the exponential depreciation. That's what I put in y1. And then it'll graph the straight line, which is my y2. And unfortunately, the calculator decided it wasn't going to show me the important part, which I wanted, which was where these two things meet. So let me zoom out a little bit. Let me zoom out. And I would like the calculator to zoom out over here, which is where I care about. I care about where these two things intersect. So I want it to zoom out there. Okay, there's my curvy line again when I'm zoomed out. Then here comes my straight line, and they intersect right there. I want to find out what this point is. Well, one of the ways I can do this, I can kind of move that cursor around until the plus is like right on there, and I can kind of see when x is 19, and what is 19.9 actually? What does that say? It says in 19.9 years, they'll be approximately both equal 8,863. Another way to do this is to go to your table. Go to your table and look for when the two prices are the same. Right? You're looking for when these two prices begin to equalize, and we just happen to know that, oh, it looks like around 20 years. Around 20 years, they come really close. Yeah, 19.9. That makes sense, right? Okay, so that's how we did it. They went through this, and they found that that these two things will equal at a certain price. So they gave us a new expense equation. All right. Let's see. Let me see. If I asked you a question, describe this situation in this graph or on this table after 4 years, what could you tell me? Can you answer a question like describe the situation pictured above after 4 years?
No.
No. Okay. Yes?
No.
Mari, do you have a sibling that's volunteering you for answering some questions?
No, he was talking to his teacher.
Oh, okay. All right. Well, I mean, so if I have these two things graphed in my calculator, I can go to year 4. That's X's are years and what we're working with. I can say at year 4, the car will have depreciated to be $21,213. And, there would be $2,200 of expenses at 4 years. So at 4 years, the car will have depreciated to $21,213. $213. I'll need a dollar sign there. With $2,200 of expenses thus far. So we're saying that, okay, where is this thing at year 4? I don't think these two graphs are the same thing. I'm graphing something different. I'm talking about the exponential system of equations. Fortunately, we're almost done here because I think next is example. Okay. All right, I'll give you a second to get this down. I just want you to be able to take a look at 2 different equations, put both equations in your calculator, and find out, be able to describe situations at certain times. There's this idea that you can stick equations into y equals. You can find out what's going on at any given year by looking at the table on your graphing calculator. Example 6, we are going to skip. I'm not going to worry about example 6 because it has to do with natural logs, and we just don't need those right now. Not in a COVID year. All right, let's see. Example 5, a car exponentially depreciates at a rate of 6% per year. Beth purchased a 5-year-old car at $18,000. What was the original price of the car? Let's just run down what's going on here. Here's our sample exponential function, right? 18,000 is the price now because it's 5 years old. After it's 5 years old, it's 18,000. We're going to find the original price. We're going to solve for A. So here's how we're going to do it. We're going to, A is being multiplied by this big expression. So we're going to divide this big expression on both sides of the equation, right? So 18,000 divided by, right? Let me go to my calculator and show you how this works. 18,000 divided by 0.94 raised to the 5th power gives me $24,526.37 cents. And that's exactly what A is. That's the original price of the car. If I gave you a problem like this, you'd say, okay, you follow the same situation. It's 30,000. It's 30,000 after 9 years. Okay, there's my 30,000. I'm going to divide by the rate expressed as a decimal out of 1. So what's 5%? What would be so 5% expressed as a decimal out of 1 would be 0.05, but I need to then it needs to be 1 minus that, right? So it'd be 0.95. Or you can just do parentheses 1 minus 0.05, whatever you want to do. In my head, I do that easily enough in my head. I would call that 0.95, and I don't want to raise this to the power of 9 because I have 9 years in my problem. So originally, this car must have been worth $47,600. $47,600 would be the original price of the situation here. I've got this one left for you. There's just one left for you. Car depreciates at a rate of 7% a year. I'm going to let you go ahead and tackle that one. We have 3 minutes. I'll let you give 1 minute to tackle it, and everything else after this is bonus. There's no big content questions besides the example 6 stuff. So let me give you a minute. Work on this one here.
Fine.
I got to have you do a couple of these on your own, Good participation today, though. All right, with 1 minute left, let me just run through this. 20,000. Oop, not a Z. I want a 20,000. 20,000.
So,
right?
Mister, isn't it
Yeah.
28,000, 28, I don't know, but it has a negative, so I don't know if it's right.
Let me see. So it should be, you should have had 20,000 divided by, you should be
Yep.
divided by either 1 minus 0.07 or it should be 0.93. Which one did you have?
0.07. 1
Okay,
minus
so now,
0.07.
okay, and did you raise it to the 5th power?
No, that's what I messed up then.
Yes, if you raise it to the 5th power, because it's 5 years, that means it'll be 28,748 was the original price. So the car was originally 28,748, but then after 5 years, it became 20 grand. Okay? Happy Tuesday, Yomari. Happy Tuesday. Javier, happy Tuesday. I'll stop the record.
All right, bye.
Have a great day.